Hello! In this video, we are going to prove the following theorem. Suppose G is a group and A, B, and C are elements of G. If AB is equal to AC, then B is equal to C. If BA is equal to CA, then B is equal to C. Now, let's remind ourselves, if we're given a group G with identity element E, then from the definition of a group, the following three things hold. The first thing is associativity, which says for all A, B, C, and G, this equality is true. The second fact is regarding the definition of the identity, which says the following. For all A and G, AE is equal to A, which is equal to EA. And the third fact is that every element of G has an inverse. In other words, for all A and G, there exists an element of B and G such that AB is equal to E, which is equal to BA. Okay, so now let's get into proving this theorem. To start out the proof, since every element of G has an inverse, then in particular, A has an inverse. And so let's say that T is an inverse of A. And to say that T is an inverse of A means that AT is equal to E, which is equal to TA. So now, remember, the whole goal is to prove 1 and 2. So let's start out by proving 1. To prove 1, we want to prove if this is true, then this is true. So let's assume that AB is equal to AC. The whole goal is to deduce that B is equal to C. And we can show this through a chain of equalities. We know by definition of the identity that B is equal to EB. We also know that E is equal to TA. And then, by associativity, we can move the parentheses around AB. But then, AB is equal to AC. And then, using associativity again, we can move the parentheses around TA. And then, we know that TA is equal to E. But then, by definition of the identity, EC is equal to C. So this shows through a chain of equalities that B is equal to C. And therefore, if AB is equal to AC, then B is equal to C. So this proves 1. Now let's prove 2. To prove 2, we're trying to show if this is true, then this is true. So let's assume that BA is equal to CA. And again, through a chain of equalities, we're going to show B is equal to C. We know by definition of the identity that B is equal to BE. But then we know that E is equal to AT. Then, using associativity, we can move the parentheses around BA. But then, BA is equal to CA. And then, applying associativity again, we can move the parentheses around AT. But then, AT is equal to E. And by definition of the identity, CE is equal to C. So, through a chain of equalities, we've shown that B is equal to C. Therefore, if BA is equal to CA, then B is equal to C. So that proves 2. And so this completes the proof. And so yeah, that's pretty much it for this video.